Welcome to this lecture on matrix algebra with the Google Colab for Python. We are excited to have you join us as we explore the powerful tool and techniques for performing matrix operations using Python. Throughout this lecture, you will gain hands-on experience with Google Colab, a cloud-based platform, and deepen your understanding of key matrix algebra concept essential for various computational applications. Matrix algebra with Google Colab for Python enables users to perform efficient matrix operations using Python libraries like NumPy, SymPy, Matplotlib, and SciPy. Google Colab provides free cloud-based environment for executing Python code, making it easy to explore matrix algebra concepts such as matrix addition, subtraction, multiplication, inversion, and eigenvalues, eigenvector. This setup is ideal for learning and applying matrix operation in real time without local installation requirement. So let's start with the topic of matrix algebra practicals. And the agenda of this session, we are going to cover introduction to the software and command related to the topic. Computational of addition and subtraction of the matrix, computational multiplication of matrices, then computational of trace and transpose of a matrix. Computation of rank of matrix, computation of matrix, solving the system of homogeneous and non-homogeneous linear algebraic equations. And at the end, we will compute eigenvalues, eigenvectors, applications of diagonalization of matrix. So this is the main agenda during this lecture. But some of the partial part of this lecture cannot be covered during one lecture, so we will divide in two parts. So as much we try to cover in the one session, otherwise the partial part we will cover in the next lecture. So very first we have is introduction to the software and command related to the topic. So as I beginning told you that we are using Google Colab for this computation. Google Colab, short of for Google Collaboratory, is cloud-based platform that allows users to write and execute Python code directly in the web browser. It is particularly popular for data science, machine learning, and artificial intelligence projects. Colab provides free access to powerful computing resource including GPU, CPU, TPU, making it ideal for tasks that require significant computational power. And there are several Google Colab features which include, very first is integration with the Google Drive for saving and sharing files. All the tasks which you will create in the notebook of Google Colab will be automatically saved in the Google Drive, and we can easily access and we can share with anyone. Next is support for popular libraries like TensorFlow, PyTorch, NumPy, etc. So all type of the libraries which are required for data science, data analytics, machine learning, and scientific computing are provided by Google Colab. And if some of the libraries are missing, we can easily install for the same. Real-time collaboration similar to Google Docs, enabling multiple users to work on the same notebook simultaneously. And the last important thing is easy to pre-configured environment for machine learning and data analysis without needing to install anything locally. Colab is highly suitable for researchers, educators, and developers working on machine learning project tutorials or data analysis tasks. So here first I would like to let you know how we can create the Google Colab notebook. So just you need to require only your Gmail account in Gmail, and by using the same we can easily create our first notebook. So I am explaining here everything step by step, just you need to follow my instructions. So what you will do in the Google, you just search Google only Colab, search here Colab and then enter. So in the top you will find that we have welcome to Colab. This is the official URL for Google Colab, and which is the URL official we have is colab.research.google.com. So as soon as you will click on it, you will see that at this place we can observe in the blue button new notebook. Just you need to click on it. So the first new notebook will open. It will take a few seconds. So here you can see that this is the first notebook, and yes, and here you can update the title for the same. So here we can give the title first file with Colab, and then you can see that here are two parts. One is code and the second is text. So here you can insert your text. Suppose I want to give the title for this file matrix algebra. I give the title for this file matrix algebra. Okay, and if you want to make this font a bold font, just you need to click after selecting, and on the right hand side you can see that the font style is now bold. Sometimes if you need to increase the font size, we can easily do by using hash and space. So this is the full size of the matrix algebra. If you will shift and enter, so this is the title, and select on it. By using this upward arrow sign and arrow sign, we can move this shell upward or downward. The title of this file must be on the top. Then after here you can see that if you need some more instructions you want to insert or you want to edit, just you need to double click on it, and you can modify it with the applications. Okay, and here when you will enter, just you need to enter we are using Colab for this computing. So all the description, if you need to insert, you can give here, and many more. Again, shift and enter, you can have the title. After that, this one we can insert the statement, and the Python also work like a calculator. We can easily insert the statement at this place. See here, if I have 2 plus 6 plus 9, and when you will execute this code, yes, you can see that at the bottom the sign, the circle is in orange color, and here is also the file is connecting, and now it becomes green. So our file is connected with the cloud computing, and here now two options are available, RAM and disk. We can check Python 3 Google compute engine backend, and the RAM is we can check the RAM, which is 12.67 GB, and disk size we have is 107.72 GB, but RAM is we are using here 1.13 GB, and that of disk we have 32.54 out of 107.72 GB. So as soon as the file is connected with the cloud computing, we have the output. Also you can modify this statement. Say we add one more number, which is 89, and when you will execute, so in this way this Python interface will work as calculator. So you can easily do all type of simple operations, mathematical. Okay, see here, if you want to divide 89 by 2, and just you need to play this code, or either to run the code you can press control and enter. So by pressing control and enter, the code will execute. You can assign the value just like A is equal to I have is 8, B is equal to I have is 7, and C is equal to I have is 2, D is equal to I have is 9. Okay, and E is equal to I have very simple operation we can do here, A plus B plus C minus D. Okay, so this is the basic operation, and we can divide it by 5. Okay, so then again enter, and for the print we can use here E. So this is a very simple. Here the meaning of this statement is A is the assignment variable, and equal sign is used for the assignment. 8 is the value. So the value of A is 8. Similarly, that of B is 7. That of C is 2. D is 9. And E equal to, we have the operation which is A plus B plus C minus D upon 5. So when we will execute this shell, this will compute the values and return the value at this place. Okay, so this is the just a very simple shell are there, and we can do several operations here. Okay, now I would like it to come back with the file I have prepared for you, so that we can easily do all the experiment in very less time. See here, for our current session, we are using SymPy, a symbolic mathematical library. Symbolic mathematics plus Python. The combined two, we have the library SymPy. SymPy is a Python library for symbolic mathematics, allowing users to perform algebraic computations symbolically rather than numerically. It is widely used in scientific computing, research, education, to manipulate mathematical expressions, solve equations, and perform calculate operations symbolically. The meaning of symbolically is that just like we want to solve the differential equations, and the result which we will obtain will be again in the form of the values, variables, and the parameters which are involved in differential equation. Second, you can take the example of like square root 2. Okay, so when we are using the symbolic mathematics, this will be under root 2 and return the value under 2 only. But the numerical value of square root 2 is 1 point something, which is not equal to under root, because the exact value is we required for different type of the computations. That's why we required a symbolic mathematics. So here we need a SymPy library, and the syntax for the same here you can easily observe to how we can import from SymPy. Import this one. So by using this statement, we can easily import Python statement, all the functions, classes, and objects from SymPy library into the current namespace. So here we have the shell where the code has been created, and also I let you know that at the end I will share this file and let you know where you can access this file for your use. Okay, so here first we need to import this SymPy in Colab for this notebook, and after importing the SymPy, we can do several expressions, experiment what we need or required. So give the statement, and also you can see here the first statement and hash is there. So hash is used for comment, and this is the just description what we are doing here. So we need to import all functions, classes, and object from SymPy, and for that cause we need SymPy import this one. So by using this statement, we can have all the functionality to do all type of the operations which we need. First, you need to execute this statement so that the file will be ready to execute all the statement. Okay, what we need different type of the operations. So very first we need to if you need one more shell, you can press this code sign. This is new shell. So first we need to create matrix. So to create the matrix, we need to use matrix function, which is inbuilt in the SymPy. Okay, this is matrix, and in open bracket you will use this square bracket, and all the element 1 comma 2 comma 3 will be inserted. So when you will execute this statement, this is, we have column matrix, and for row matrix you need to insert one more bracket, left and right. So now when we will re-execute this statement, this is row matrix. Yes, if you have more rows, or you want to add one more row, just use add space comma and add one row of the same order. 3 columns are there. Okay, so we are using here 2 comma 3 comma 4, and when you will execute, you can see that we have matrix of 2 by 3 order. And further, if you want to add one more row, we can do just like 5 6 and 7, 5 comma 6 comma 7, and execute it. Now we have the matrix is 3 by 3 order. So in this way we can easily create a matrix using SymPy. And here you can see one more example is here. Matrix, this is the first row element 1 minus 1, this is the second row element, this is the third row element, and when you will execute, you can see that this is a 3 by 2 order matrix. And here I have insert one more example to make it easy. Make column vector a list of element to consider to be column. Just you can see this is the example earlier we have already discussed. Yes, so this is the column matrix. And matrix are manipulated just like any other object in a SymPy or Python. And here you can see that we have 2 matrices are there. Very simple example. I have choose add space. M is equal to matrix 1 2 3 and 3 to 1. Here are 2 rows, and in this second matrix n equal to, we have only 1 row. If you want to check their order, you can check the matrix. Yes, M is equal to, we have is 2 by 3, and that of n we have the matrix only column matrix. Okay, and when you want to multiply M product n, so this will return the product of these 2 matrix. So this is the product of the matrix M and n. Okay, so here we have the some more basic operations, and if you need to addition and subtraction, in that case we have to choose some more matrices of the same order. Here we are taking M is equal to, this is the matrix. Okay, matrix, and element are 2 comma 3 comma 4. This is 3 by 3, and we take 3 by 3 order matrix. Okay, and here we will take the element 3 comma 4 comma 5, and then again comma, and this is 4 comma 5 comma 6. Okay, so when you will execute, see what happen. This is showing some error because here this is the row these are the row elements. We need one more bracket at this place, and on the right hand side also. Again execute, and you will find that this is, now we have M matrix. If you want to print, yes, this is M matrix. Again we need one more matrix. Okay, we have n is equal to, and we are copying this element, copy and paste here. So we make some element change from this place. This is minus 4, this is 7, here is 8, this is 5, and here is -5, this is 9. Okay, so if you want to check this matrix, n is equal to, so this is the matrix. If you want addition, of the matrices, okay, so what you will do, m plus n, and when you will execute, we have the addition of the above two matrices. And take one more new shell. Okay, and if you want to subtract, this is again very simple. Subtraction of matrix, subtraction of matrix, just you will use added space minus. So this is the subtraction. Okay, and if you want to multiply, we have already discussed this part. Now we have some basic operations here. If sometimes you need to check the shape or order of the matrix, so for that one more function is required. So here from SymPy import this product sign, all type of the functionality is there, and for to check the shape or order of the matrix, we will import from SymPy import shape function. Okay, and this is the M matrix. When you will execute, we have this element, and if you want to check the shape or order of the matrix, we will use this shape function in this way. Shape, in the parenthesis we have M, and when you will execute, you can see that the order of the matrix is 2 by 3. So this is very quite simple way to execute all these statement. And next you can see how we can access rows and column. Okay, so to get an individual rows or column of a matrix, use row or call, for example m dot row 0. So we'll get the first row, m dot row 0 will get the first row, and m dot column -1 will get the last column. See here how we can manipulate all these. Here we are taking this matrix m is equal to 1 2 3 -2 0 4. These are the element of the matrix. Now if you want to access the first row of the matrix, I want to increase one more row in this matrix. Here is one more row, and element are 3 5 7. Okay, execute. So now you can see that we have 3 by 3 order matrix. Now here we want to access the first row of this matrix. In Python, the index start from 0. So 0 means first row, and 1 means second, 2 means third. So here you can check it. When I will execute, this will access only first row. Okay, if I am using here 2, see what happen. If I execute here 2, and yes, 2 means third row, 2 means third row, 3 5 7, these are the third row. Third row element has been accessed. And if you have -1 and again execute this one, so when you are using -1 to access the row, this will be the last first row, first from last. Okay, 3 5 7 and 3 5 7. If you have -2, then this will be the -2 0 4. If here we have is -3 and execute, this is the first row. So -3 means 3 from last. Okay, so in this way we can access the rows. And now we are talking about how we can access the column. So here when we are using -1, so this will access the last column of the matrix, and you can see that the last column is 3 4 and 5. Okay, if you are using here 2 means third column. Yes, 3 4 7. So, and if you are using here 0, then this will access first column. Check it, 1 -2 and 3. So in this way we can easily access row and column from the matrix. If sometimes we need to delete any row and column, and also we can insert by using some statement and the functions which are available in the Python. Here we have the matrix, and I want to insert here one more row so that this become 5 8 and 9. Okay, this is now the matrix of 3 by 3 order, and the element are 1 2 3 minus 2 0 4 5 8 9. If you want to delete any row of this above matrix, so what we will do, if you are using here 0 m dot call underscore del, so by using this statement, this will delete the column, and if you are using here 0, this will delete first column. Execute. Yes, you can see that in this new matrix the first column has been deleted. If you will again execute, see here is only 3 4 9, because the in the previous we have one column was deleted and two column element are 2 3 0 4 8 9, and when the values are updated at this place, so again when you will execute this statement, the first column has been deleted and we left only with this last column. So if you need to only delete second column, first you need to update. Okay, now we can delete the second column. See, now you can see that the element of second column 208 are deleted, and we are left with the first column and the last column. Okay, so we need to update first this information after deleting the column or row. Okay, similarly, if you want to delete row, first I am going to update this matrix, and then we can delete just 1 minute. Okay, we can delete the first row, and to delete the first row we have to use at the place 0, and you can see that the first row element are 1 2 3, second minus 2 0 4, third 5 8 9, and in this matrix you can observe that minus 2 0 4 5 8 9 first row has been deleted. If again you will execute the same statement without updating the matrix, we are left only with the last row, because in the first execution first row was deleted, and the second execution second is also has been deleted, because the second row become first row when we delete the first row. Okay, again if you will execute this part, matrix now be updated, and now if you want to delete the last row, for that we have to use 2 second index. Okay, and execute. Now you can observe that the last row of this matrix, the element are 5 8 9 has been deleted, and we are left with this matrix. So this is the way how we can delete any row or any column from the given matrix. If you want to insert any row or column, this is also very quite simple. See here, this is the matrix M. Okay, and if you want to insert this matrix and element are 2 4, and execute, when I will execute this part. Okay, and here this is the row. Okay, but here this is the row, and we can choose column. We can choose column, and when you will execute, sorry, the problem is that 0 4, just 1 minute, number of column, insert 1. Yes, so here you can see that M is equal to 1 3 minus 2 4, and we can insert M dot row insert. So if the row element are 1 2 and minus 2 4, okay, so we need the same column to insert row matrix. So here when you will use 1, then at the second place this element has been inserted in this matrix, and the elements are now 0 4. Similarly, you can insert column, and the matrix M we have is this one, and if you want to insert here column, so for that we must have one more element at this place. 3, and now you can insert this matrix. Yeah, so 1, -2 and 3, these elements are inserted in the first column in the above matrix. So in this way we can easily insert row and column in the matrix, as well as we can delete row and column from the matrix. Now here we have again some more examples for the addition, subtraction. Just we need to go through the examples. I have repeated some examples. So addition, you can use m plus n. Yeah, we have these two matrices, and m plus n return the addition of the matrix, and m minus n will return the subtraction of the matrix. If you want to multiply the above two matrices, then you will use m product n. This is the multiplication of the matrices. Okay, frequently we are repeating this example. Again, we have the scalar multiplication. If you want to multiply the matrix m by any scalar, we can do 3 product m. Yes. So this is the scalar multiplication. All the element of the given matrix will be multiplied with 3. Power of the matrix m product 2 times. This is the exponent of 2. The meaning of this expression is m product m. Okay, and this will return this matrix. If you are using here m cube, this will return matrix m product m 3 times. If you are using here 5, this is the product of m matrix with m 5 times. You can do easily. And if you want to find out the inverse matrix of a given matrix, this is again very simple. You will take m product 2 times -1. The meaning of this statement is m exponent -1, and when you will execute, this will return the inverse matrix. And also we have this statement to find out the inverse matrix, m dot inverse. Okay, and when you will execute, you can see that the values of both the operation are same. And here is n matrix. If you want to find out the determinant of any matrix, then we are using det function, which is used for determinant. Yes, the determinant of above matrix we have is 0. If you want to find out the transpose of any matrix, this is again very simple. To find out the transpose of any matrix, take the transpose of a matrix, use t. See here we have these statements are usual. We have m matrix. When you will execute, and see that we have the matrix having the element 1 2 3 4 5 6, and for the transpose you will use only m dot t. This will return the transpose matrix. So now you can see that the rows are transposed into column, and then after we have m1 matrix. m1 is equal to, we have matrix 1 2 3 4 5 6 3 4 5, and when you will execute, the m1 matrix will be equal to, you can check the first row element, second row element, third row element. Okay, and to trace the matrix, trace is nothing but the addition of all the diagonal element. 1 plus 5 plus 5 is 10. So in this way we can easily find out the trace of matrix, which is 11. There are several constructions of the matrix which are required sometimes for different type of purpose, and several constructions exist for creating common matrices. To create an identity matrix, use IN, and IN will create n by n identity matrix. See the example. I is a function, and when you will use here I3, this will be identity matrix of 3 by 3 order. If you are using here 5, then this will return the identity matrix of 5 by 5 order. You can check it. Okay, and to create matrix of all zeros, zero matrix. Okay, so here if sometimes if you need zero matrix of a 2 by 3 order, then you will use zeros 2 comma 3. This is the 2 by 3 order zero matrix. If you have 5 by 7 order zero matrix, you can execute. So whatever you need the zeros matrix, you can easily use this zeros matrix function. This will generate the zero matrix according the requirement. And similarly, we can create the ones matrix, which is all the elements are 1. And see here, when I will execute, so all the elements, this is 3 by 2 order matrix, and all the elements are 1. Okay, just you need to put this single statement, ones parenthesis 3 comma 2. Then after, how we can create a diagonal matrix using this function will be used for the diagonal matrix. The arguments to the diagonal can be either number or matrices. A number is interpreted as a matrix. The matrices are stacked diagonally. The remaining elements are filled with 0. Check it. Very simple. When you will execute here, the element are 1, 2, 3. So this is the diagonal element, and the diagonal elements are non-zero, but other elements you can see 0. And also when you will execute this statement, diagonal -1, ones 2, 2, and matrix 5, 7, 5. And when you will execute, you can see that we have this matrix -1, then we have the diagonal element 1, 1, 1, 1, and other elements are 0. Okay, and then we have this matrix. This is just a column matrix 5, 7, 5, and this is at this place, and you can see this the diagonal matrix, and other are 0. So the argument to the diagonal, as we described earlier, can be either number or matrices. A number is interpreted as the matrix. The matrices are stacked diagonally. The remaining element are filled with zeros. And this is the example how you can use. And for the determinant, we have one more example here. M is equal to, this is the matrix when you will execute. And to find out the determinant, you can use M dot DET. So in this way, you can also find out the determinant of the matrix. So here the last part we have is eigenvalues, eigenvector, and diagonalization. So to find the eigenvalues of a matrix, use eigenval. This function is required. Eigenvals. Eigenvals return a dictionary of eigenvalues, algebraic multiplicity pairs similar to the output of the roots. So here we have, this is very simple, matrix of 4 by 4 order. Okay, and to find out all the possible eigenvalues, I am not discuss more detail about the eigenvalues and eigenvector. You must be familiar about what are the eigenvalues, eigenvectors, and what do you mean by diagonalization. So you must cover the subject first, then you can use this computing part. But because we are doing only the computing by using this Colab, so I am not have sufficient time to explain about all these things. So before using, you must clear the fundamentals about all these things before using. So to find out the eigenvalues, you will use m dot eigenvals in this way, and this will return all the eigenvalues. So this is the first eigenvalue, 1 time, -2 is the second value, this is also 1 time, and 5 is the eigenvalue, which is 2 time. So the meaning of this statement is eigenvalues are -2, 3, and 5. The eigenvalue -2 and 3 have algebraic multiplicity 1. The eigenvalue 5 has the algebraic multiplicity is 2. And if you need to find out the eigenvector, then we will use this statement m dot eigenvects. So this will return all the possible eigenvectors corresponding to the eigenvalues. So here we have all these are eigenvalues. So corresponding to -2, this is the eigenvalue, and this is the eigenvector. The element of eigenvector are 0, 1, 1, and 1. Then we have the next eigenvalue is 3. Okay, and the eigenvector is 1, 1, 1 and 1. These are the eigenvalues. Again, corresponding to 5, we have multiplicity is 2. That's why we have two eigenvectors corresponding to 5. One is 1, 1, 1, 0, and second we have is 0, -1, 0 and 1. So these two vectors are corresponding to 5. So in this way we can easily find out the eigenvalues and eigenvectors. This shows that the example, the eigenvalues 5 are also geometric multiplicity 2 because it has two eigenvectors. Because the algebraic and geometric multiplicity are the same for all eigenvalues, M is the diagonalizable. So to diagonalize the matrix, we have to use this process. To diagonalize a matrix, use diagonalize, and this will return the tuple P comma D. D is diagonal matrix and M equal to D P D inverse. Okay, so when you will execute this statement, this will return two matrices. One is P, which is this one, 0, 1, 1, 0, corresponding to the eigenvectors. So this is the first vector, this is the second vector. All the columns are the eigenvectors of the matrix. Okay, and this is the D. You can see this is the diagonal matrix. So this is the first eigenvalue, second eigenvalue, third eigenvalue and fourth eigenvalue. So two eigenvalues are 1 time and 5 is 2 time. And after that we can calculate PDP inverse. So this is the code for this one, PDP inverse, PDP inverse. Okay, PDP inverse. So when you will execute, we have this matrix, and at the end we can check whether PDP inverse is equal to M. Yes, which is true. So this is all about this session, and the content which we propose for this has been covered. Two things which we did not cover. One is solving the system of homogeneous and non-homogeneous linear algebraic equation, and one is rank of matrix. So these two parts will be covered in the next session. Thanks to watch the video till the end. I hope this lecture on matrix algebra with the Google Colab for Python has been insightful and provided you with valuable skills. The lecture file will be uploaded to Google Drive, and you can download it by following the link provided in the YouTube description. Thank you for your participation, and we encourage you to explore further. Thank you.